Hi, this is Dennis. I have several questions from several students about the decision statement assignment. So I'm basically going to have this video to create that assignment for you. First thing you should do is read the program specifications. This program requires a student to write a C program and a design tool for the following specs. The user program will ask for 3 characters from the keyboard, one at a time. So something like enter the first character please and then get it. Enter the second character please and then get it. And enter the third character please and then get it. Then there's 3 simple statements. One is going to be happy, sad, or dead. You're going to do a test to see whatever the first character was, if it comes, or if it happens to be equal to the second. And as long as the third character is not a capital Z, then you're going to say happy. You're going to do this with sad. You're going to test the first character to see if it's before or less than the second and third. If so, you're going to say sad. And then you're just going to make something up for dead. So here is pseudocode for the exact same problem. First, I'm going to prompt the user for a character. I'm going to read it in. Then I'm going to flush out the keyboard. We'll talk about that. And then I'm going to repeat this for a total of 3 times. Then I'm going to test to see if the first character equals the second character and the third character is not equal Z. If so, I'll display happy. Then I'm going to test to see if the first character comes before both the second and third. If so, I'm going to display sad. Then I'm going to make something up to display dead. So there's my pseudocode, and that would be in a separate document. Now I'm inside my CIDE, and I'm going to have a comment header. It says written by myself when I wrote it, purpose, and it's going to say see below. Matter of fact, I don't even know if I need that there, but anyway, I think this might look better. Something like that. Purpose see below. Ask the user for 3 characters from the keyboard. Say happy if the first is equal to the second, as long as the third character is not equal to capital Z. Same rule we had before about sad, and then we'll make one up. Okay. So now, let's talk about the program itself. So I'm going to just expand this, and then I'll get started. So like any program, after my comment header, I'll have my preprocessor directives. Here I'm creating an alias for system pause, and it's a constant. So constants are in capital letters, and I'm calling that pause. So I can either type this for a pause or this for a pause. There's my 2 standard includes. Here's the beginning and ending main. And now, if you remember from the design tool, I need 3 variables. They're all going to be of type char, and it could be char1, char2, char3 if I wanted to. Typically, if it's a type char, you're going to initialize it if you choose to. You're going to initialize it maybe like that. That's a space. And notice those are single quotes, not double. So to initialize a char, we use single quotes, not double quotes. To assign a character, again, single quotes, not double quotes. So this is kind of overkill, but should I have wanted to default them, there I am. So there's my 3 variables that's going to read in my first, second, and third characters. So I'm going to say printf, and I'm going to say please enter the first, please enter one of 3 characters from the keyboard. So there's the prompt. Nothing major there. I like my colon after a prompt, and I want a space after my colon. So here I'm going to scan it in, scan F, and when I scan a character, it is %C for my placeholder and ampersand char1. So this is actually going to work, and we can test it. So here we go. So it says please enter one of 3 characters from the keyboard. So I enter a character and the program ends. So that's pretty good so far. But I'm going to show you a problem. So now I'm going to just copy that 2 more times. Copy that 2 more times so that I can get my second and third character. So this will be my third character, character number 3. This will be character number 2. And this will be 2 of 3 and 3 of 3. So So there's my prompts. It's going to prompt the user, please enter one character of 3, then 2 character of 3, and then 3 character of 3. Let's run that and see what that looks like. So the program runs, and it says, please enter the, kind of poor grammar here, but the one of 3 characters from the keyboard. So I'm going to enter anything I want, so let's say a capital X. Notice what just happens though. Please enter the second of 3 characters from the keyboard. Kind of gets skipped. Not kind of, it does get skipped. And it kind of wraps right down to enter the third of 3 characters from the keyboard. So it skips over that second character. So let's talk about why that happens. And the answer is C is a lower level language, which is a good thing. Which means I can get down to like memory level, I can get down to the hardware level, and so on. So as we know, maybe from the past or before this class, if we type sometimes, we could type so fast and our computer could have so many apps open that there's a lag between as we type and what appears on the screen. So we may be typing way down here and this part may just start appearing on the screen. So the question is, if I'm typing down here, where was this before it went to the screen? And the answer is, inside of the keyboard, there is something called a keyboard buffer. And that's nothing more than a piece of RAM that temporarily holds information as we type before it gets consumed out by some other program. So the keyboard buffer. Well, here's the problem. And when I go to, when it says please enter the, maybe I like the first of 3 characters from the keyboard, and then the second of 3 characters from the keyboard, and the third of 3 characters from the keyboard. So when I say enter the first, the prompt is waiting right here, and then the user types something like, say, H. But they don't just type H, they type H and they press enter like that, because it's a 2 keystroke combination. Well, what happens is both the H and the enter, which is kind of like an empty space, but it's recognized as a character, both of those go into that keyboard buffer. Well, this scanf is only scanning a single char, which means that enter that we pressed is sitting inside that keyboard buffer. When I get down to this second scanf, what it does is it does not wait for Dennis or you to type something. It takes the next thing from the keyboard buffer, and that's that enter, meaning it skips over here and goes right to here. Or char2 equals enter. And in this case, we don't want that to happen. We want to clear out what's in that keyboard buffer before this happens. And there is a simple little algorithm or function that enables you to do that. And that's called the scanf. I'm sorry, not the scanf function. It's called the flush function, the flush function. And I'll show you what that looks like. It looks just like you see it right here. You're going to type void myFlush, left and right paren, mustache, wow, get char, left and right paren, not equal, in single quotes, /n, finish off the parenthesis, semicolon, and a mustache. You must place this line up here before main in your code, exactly as you see it. The other thing I like to do is a pound define. So you're going to see later this thing called myFlush is actually a user-defined function, just like main is. I'm going to give this user-defined function an alias, just like I did with system pause, and I'm going to call it all capital letters flush, because it's going to be a constant. So the key is, anytime I'm reading characters from the keyboard, I should always flush the keyboard buffer right after the scan. I wish C didn't do this, or I wish they had a way to turn it off, but it is what it is, and I can't control it. Well, I can control it, and this is how I control it. I control it by flushing out the keyboard, flushing out the keyboard, and flushing out the keyboard. Watch when this runs. So when this runs, it says, please enter the first character of 3. So I type anything, C. There's the second of 3. I type anything. And there's the third of 3. So those 3 characters are all there, and the world's good. The world's good. Okay. So the second thing I'm going to do is I'm going to say happy if the first character is equal to second, as long as the third character is not equal to capital Z. So let's see how that can work. And I'm going to do that right here. So I'm going to say if character 1 equals character 2 and character 3 does not equal a capital Z. I believe that's what I'm supposed to say. And let's take a look. So if the first character equals the second character and the third character doesn't equal capital Z, then I'm supposed to just print happy. Something like that. So now you might say to yourself, hey, self, how did that just do whatever you just saw right there? How does it know if two characters are equal, or how do they know if something is not equal? I'll show you that in a minute. Let's just do the next one. And the next one says, if char 1 is less than char 2 and char 1 is less than char 3, then I believe I'm going to print sad. So I'm lazy. Let me copy this and paste it. And this is going to just become sad. S-A-D. Something like that. And again, how does this work? Now I'll show you. I'm going to show you. So what you need to do is you need to go out online to somewhere maybe like the Google and ask this question, the ASCII table or chart. Ask for an ANSI table or chart. So what is an ANSI table or chart? I'm going to actually show you one because I just Googled it over here on my secondary screen. And this is an ANSI table or chart. So what you're going to see, these are all the possible values or characters on the keyboard. Now these are the ones we really know. We know space and exclamation point and all of these guys. And then we know cut capital letters and these guys and lowercase letters. Well, if you look across from a capital A, it has a decimal number of 65. Well, that decimal number is what the computer actually compares things with. So if they enter an A and I'm testing to see if it came before an E, it would be like behind the scenes the computer would say, is 65 less than 101? So it does the sorting or ordering according to this ASCII chart. And just to let you know, there's an extended ASCII chart too. Just want you to see this. You'll never be questioned or tested on it. So that's how the sorting takes place. Let's see if it works. So we're going to enter 3 characters from the keyboard. We'll enter A and Z. That should not say happy, and it doesn't. And should it have said the other? No, because the first is not less than itself. The first is less than the second. So we'll test it one more time. I'm sorry, I think I had that output on the other screen. I'll test it one more time anyway. So here is my first character. I'll type a capital A and then a little a. Well, we know a capital A is 65, and I think a little a is like 97. So 65 is less than 97. And then we'll type a little z. That's not a capital Z, so this should say happy. I'm sorry, sad, because this comes before the first, this comes before the second. So that is definitely sad. Sorry, my bad. Let's do one more. Let's make it say happy. Happy is simply where the first equals the second, so let's just go big X, little x, and the third does not equal a capital Z. Happy. And then we just had to make one more thing for dead, I think, and we could have just said anything we want. We could say if char 1 is greater than a capital A and char 1 is less than a capital Z. What I did there is I should have had inclusive all the capital letters. So if they enter any, let me say less than or greater than, or greater than or equal to, less than or equal to. So if they enter any capital letter, it's going to display or print dead. If they enter anything but a capital letter, then it's not. And I'll just do this just for the fun of it. if I can only type. And I'll say print not dead. Alright, so now I'm going to get dead or not dead depending on this guy right here. So I'm going to type a capital letter for everything. So I'm going to type a capital A, a capital B, or N, and a capital F. So here I go. I'm going to type a capital A, a capital N, and F. So they're all capital letters. So I'm only testing the first one. So since this is an A, it should say dead. It also says sad, but we don't care. So you can test that again with anything but a capital letter for the first letter. So when this runs one last time, I'm going to enter a little a, and then a big A, and a big B. And notice it says not dead. So not much going on here. The only reason to show you this is because I want you to see the flush. I want you to see that you can compare characters with each other. I want you to think of good programming style. I want you to consider good program design, and just put it all together and test it, and for lack of better words, play around. Okay, this video has been 16.5 minutes. I'm done. Thank you.